Alright, so we're going to start with the law of cosine, and here I give you the equations for the law of cosine. Typically they're given to you on most exams. If you have to take it, you don't have to memorize them. But in this case, I'm just going to name this A, B, C. It doesn't matter how you name it or label it. But once you name the angles are labeled with capital letters. Lowercase letters are typically the sides opposite of those. So this is side A, this is side B, and this is side C based on how I labeled it. So that's the law of cosine. Those are the three formulas. If you're looking for this, I'm guessing you're just looking for practice. So we'll just throw a couple problems at you. You've seen it before. You know kind of what it is. How do you use the thing? So we'll start with the most basic example. So here's a pretty basic example of the law of cosine. Notice you've got a side, an angle, and a side. And typically you want to find all the rest of the information that they don't give you. So what I would do here is label it. I'm going to label it A, B, and C, which means this is little b, this A is right here, that's little a is 10, and then little c is 14. So now we'll go ahead and find angle B, or side B, sorry. And if you look at this, we're trying to find little b. So if you go back to the equations, we're looking for this one right here. So b squared equals a squared plus c squared minus 2 times a times c times cosine b. And once you do these for a while, you'll get the hang of it, and you won't have to have all three equations, but it helps you just begin with. So we're looking for b squared, and that is a squared, which is 10 squared, plus c squared, which is 14 squared, minus 2 times 14 times 10 times the cosine of angle B, which is 110 degrees. And so once you have that, you just plug that in to, well, not that. So here I have it as a Google. I always like using the Google calculator. It's pretty universal. One thing you got to pay attention to though is radians. This is in radians right now. So if you click that button there, it changes it degrees. Let me do that again. So it's in radians. Click it back over to degrees. And we're just going to plug this thing in. So if you see that, there it is, 10 squared plus 14 squared. So we'll just plug that thing right in here. So 10 squared, let me find the squared key. Guess it doesn't have one. We'll just put 10 to the second plus 14 to the second minus 2 times 10 times 14 times cosine of 110 degrees. Close your parentheses, hit equals, and 391.76 is b squared. So we're going to have to take the square root of that answer. And so I did that, and so 19.7 or 19.8 if you round that up is b. Okay, so we have b, 19.8. And now to find the rest of the information, we still need to find angle A and angle C. So let's find angle C next. I always find my angles from the largest to the smallest. We already have the largest, which is 110. Can't get any bigger than that, because otherwise you wouldn't have a triangle in a two-dimensional space. But we could have, we could find C, which will be the next biggest. And so to do that, don't use the law of cosine again, just use the law of sine. You already know the law of sine, so sine of C, which is what we're trying to find, over 14, equals the sine of 110 over 19.8. So this one's just a matter of cross multiplying to solve it. And so again, here's our calculator, so we'll plug that in. I'm going to take 14 times sine of 110. Always close your parentheses. Divided by 19.8. And you get 0.664429. Well, we're trying to find, if you remember, we're trying to find an angle C in fact. Here it is. And so to find the angle, you always have to do the inverse sine of that. So we'll hit inverse sine, so which brings up arc sine of our answer, the 0.664429. Close our parentheses, hit equals, and it's 41.6 degrees. So this angle right here, 41.6 degrees. And to find A, then you just take 110 plus 41.6 and subtract it from 180. I'll do that quick. This will give me the negative version of it, but it's 28.4 degrees because I went in the wrong direction, but it doesn't really matter. And there's that triangle solved out with the law of cosine and the law of sine. So other situation that you'd use with the law of cosine is, let's say you're given a triangle where all the sides are given but no angles are given. This is kind of the harder one, so I'm going to go ahead and label this A, that's B, and that's C. If you want to give it a shot, hit pause and see what happens. See if you get the same thing I get. You're going to use the same formulas. The key is, though, before you hit pause, you always find the biggest angle first. And the biggest angle in this case is always across from the biggest side. Well, this side's 12, so that means B is the biggest angle. So that's always where you begin. So we're going to start with B squared again, just because of how I labeled it. So this side's B, this side's C, little c, this side's little a. And again, if you go back to the law of cosine, we're going to use that middle one again. So to solve this, you would have 12 squared equals a squared, which is 10 squared, plus 7 squared minus 2 times 10 times 7 times cosine of b. So we don't know what b is. We'll have to solve this, figure this thing out. So what I do is go ahead and square everything. So there's 100 plus 49 minus 2 times 10 is 20 times 70, looks like 140 cosine of b. The problem here is you got to be really careful. You can combine these two, the 100 and the 49, but you can't combine the 140. So we've got really 144 equals 149 minus 140 cosine b. So we cannot combine the 149 and the 140 because we're solving for b, and that's 140 times cosine b. So we're going to have to subtract the 149 over. So we'll subtract 149 from both sides. I'll put it down below here. And so you'd have negative, well, 149 minus 144 is negative 5 equals negative 140 cosine b. Now you can go ahead and divide by the negative 140, and we can pull up our calculator, and we would have whatever 5 divided by 140 is. 2 negatives makes a positive, is 0.035714, blah, blah, blah. Lots of different things there. So we know cosine B is equal to that 0.01, blah, 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 whatever it was. And so we're looking for an angle. So we're going to have to do the inverse cosine of that. So we'll go ahead and do that. You hit the inverse button right there. It brings up cosine to the negative 1. We want our answer, which is the 0.0357. You can see it up above there. Hit equals, and it's 87.95. So that angle B now is 87.95 degrees. You can round that to whatever you need to round it to. Being we have a 7 is a one sig fig, the best we could do there is probably call that a 90-degree angle based on the measurement significance, but we'll go ahead and just stick with 87.995. And now it's just a matter of, again, using the law of sine. So once you have that, I always, not that it matters, but I always go with the next biggest angle, which would be A, because it's across from 10. So when we figure this one out, it would be sine of 80, and I already forgot it, 87.95 over 12 equals, we don't know sine of A, over 10. Okay, now we can pull up our calculator. Alright, so to do this, we just take sine of our 87.95. Make sure you close that parentheses, times 10, and then divide it by 12. And we end up with 0.8379999, blah, 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 lots of decimals. So we're going to do the inverse of that because we're looking for the angle. So again, we'll hit the inverse. We're dealing with sine. We're dealing with that answer that we just came up with. Hit equals. And it's 56.4. So this angle, 56.4. And now it becomes a really simple problem of taking 89.75 plus 56.4 and subtracting that from 180. So 87.95. Really, you could use 88 there, plus your 56.4 and subtracting from 180. And so 35.65. And so that is angle C, or 35.7. Really, probably at this point need to start rounding these. So that's how you use the law of cosine. You only use it one time, and those are the two situations where you use it. So I hope this helps. If you want a proof, that's coming later. I just don't have time to mess with it right now. But see you next time, and good luck.